In this section, we're going to learn about a concept called test-driven development and how we can use this to, as we develop our code, to start creating tests and somewhat do some of the work of thinking and figuring out some of these unit tests simultaneously while we create this. So let's dive into what this test-driven development concept is. Test-driven development is a concept or really a developmental process that has your software development and your testing kind of intertwined. And the idea is very centered around you create the test and then you implement the test that you've created. And we'll talk about those steps in just a minute. Test-driven development is very much intertwined or centered around incremental development, so sometimes called agile development or those types of things. And that's where you select a small little bit of what you're trying to develop and then implement those things by doing the testing. And so specifically, the overall process is first you identify the functionality that you want to implement. Next is you write the set of automated test cases for that functionality. Third, you're going to run the test suite with all the other tests. So even though you've written the test case and you haven't implemented anything, you run the test suite. And this is important because what this does is this shows that you're testing something new. So you want to have a failure. Fourth, you implement that functionality, right? Then as you go along, you rerun that test case, you update the functionality until that test passes. And then if that causes other tests to fail, then you need to fix and figure it all out. And you get all of that until number 5, you make sure that all the test cases have passed and including any older test cases. And that's called regression testing. So when you rerun older test cases, that's called regression testing. That's in there. And then finally you move on you go right back to step 1 and you start going back with that. That's in there. Now, before we get started into using kind of this test-driven development in there, there's another test suite that I want to talk to you about. We've been using unit test as a part of running our test cases, and unit test within Python is very, very helpful. PyTest is an additional module that can run tests and even has some additional hooks that you can do inside of your programming of the test cases, and you can use that to submit with that additional features, kind of build that up. Personally, I like running PyTest. There's not a huge difference between the two, except that PyTest I feel like has a better results that it prints out as far as that, and you're going to see this. However, PyTest does not come with the base set of Python, so it is something that you're going to have to install into your environment. If you installed Anaconda as a part of this, then the base Anaconda installer has PyTest built into that. And so that's what I'm going to assume is that you've got Anaconda installed on there and PyTest is in there. If not, and you're using Anaconda, you can use the command conda install pytest, or if you're not using an Anaconda environment, you can use pip install pytest to install your to pytest into your environment and start working with that. So with that, let's switch over to the Visual Studio Code and start working with this test-driven development concept. So here we have our class from previously, and including our test cases as well. And as you can see, we have our add and subtract and our relevant tests on the other side as well. And so what we're going to do is apply the test-driven development aspects to this. Now, we might be encouraged to start defining that multiply function, but we don't want to. So we're going to get rid of that, and we're actually going to create the test first. So let's switch over to the other side, and start working on our multiply test first. And that's going to be very similar to the add and subtract. We're going to do 2 random numbers, instantiate the calculator, and then assert that our calculator is doing the multiplication in the way that we expect it to be. Now that we have our test created, the next step to do is to run the test. So let's go ahead and run it. We expect a failure. And as we run, we can see that there was indeed a failure. In fact, it was actually an error. It shows that it doesn't have the attribute multiply, and that's because we haven't added that method into the calculator class. So it's exactly what we wanted it to do. Before we go any further, I wanted to share with you PyTest. So we normally run our unit tests by running the command python-m unit test. But running PyTest is just the simple command of PyTest. And so when you run it, you get actually quite a few more details about the failures, including some pretty print, and you can kind of see some rendering that's there, and you see exactly where the error is, and just generally a little bit, I feel, a better output that's in there. Now, there happens to be a warning here, and this is just because of my current environment, and it's not actually something related to the test. So now let's go ahead and start implementing the code. So we're going to implement the multiply function, just like we have with the other methods of add and subtract. We're just going to return the multiplication of the 2 objects. Then we're going to now run PyTest, and we can see, hey, all 3 of them passed. And that's exactly what we wanted to see. So now we've implemented the multiply test first, and then the multiply method. And we can see that it passes. That's in there. So that's exciting. Looks like I've got some weird warning issues, but I'll address that at another time. So let's go ahead and get started on our next piece of functionality, and that's the division. So we're going to create a test first, very similar to all the others. 2 random values for our left and right, instantiate our calculator, and do a self assertion equal of our calculator's divide versus the system's divide, and see how they do. We're gonna then, after that, we're going to remember, run the test first. So running PyTest, see that we have a failure, exactly what we expected. Now let's implement it in our code with our division, just returning the value of these 2 variables combined. Let's rerun PyTest, and there we go. Everything has passed. So that's a simple way of showing you our test-driven development, where you create the test first, run it, make sure that it fails, and then implement the functionality in your code. And then keep iterating on that until you get it correct. And then finally, you move on to the next set of functionality. Pretty simple, right? Well, when you start getting a little bit more complicated things, it does take a little bit more time, but really it is a simple task, and it's one of my favorite ways of actually developing. It helps me to think about how to actually design my code if I'm thinking about how I'm going to test it first. So hopefully this is something that's helpful to you, and you can start testing your code before you actually write it.